Now we will continue on subchapter 1.3 free body diagram. Actually, free body diagram we have two learning outcomes. The first one is explain concept of the free body diagram, and the second one apply the concept of free body diagram that reflect existing forces in the force systems such as roller, pin and feet support. Free body diagram (FBD) is the best method to represent all the known and unknown forces in a system or which acts on a body. It also a sketch of the outline shape of the body, which represent it being isolated from its surroundings. Then it's also a sketch showing the particle free from the surroundings with all the forces acting on it. The last one is necessary to show all the forces and couple moments that the surroundings exert on the body so that these effects can be accounted for when equations of equilibrium are applied. There are two common connections in FBD. The first one is spring and the second one cables and pulley. Linear elastic spring. Change in length is directly proportional to the force acting on it. Spring constant or stiffness K defines the elasticity of the springs. Magnitudes of force when spring is elongated or compressed, F equals to Ks, where S is determined from the difference in springs deformed length L and its undeformed L naught. S equals to L minus L naught. If S is positive, F pull onto the spring. If S is negative, F push onto the spring. Cables or cord are assumed to have negligible weight and they cannot stretch. A cable only supports tension or pulling force. Tension always acts in direction of the cable. Tension force in a continuous cable must have a constant magnitude for equilibrium. For any angle theta, the cable is subjected to a constant tension T throughout its length. You can see the example of cable is in tension. A rigid body is a composition of particles. Both external and internal forces may act on it. For FBD, internal forces act between particles which are contained within the boundary of the FBD are not represented. Particles outside this boundary exert external forces on the system and must be shown on FBD. FBD for a system of connected bodies may be used for analysis. You can see the example on the screen. When a body is subjected to gravity, each particle has a specific weight. For entire body, consider gravitational forces as a system of parallel forces acting on all particles within the boundary. The system can be represented by a single resultant force known as weight W of the body. Location of the force application is known as the center of gravity. Center of gravity occurs at the geometric center or centroid for uniform body of homogeneous material. You can see the example on the screen. So now, how to draw FBD? I will show you the step how we want to draw FBD. Okay, first of all, we look at to the procedure for drawing a FBD. First, draw outline shape. The second one, show all the forces and couple movements. The third one, identify its loading and give dimensions. For the first step, imagine body to be isolated or cut free from its constraint. Then draw outline shape. The second procedure for drawing a FBD is show all forces and couple moments. First of all, you need to identify all external forces and couple movements that acts on the body. The second one, indicate all the forces. Active forces set the particle in motion. Reactive forces result of constraint and supports that tend to prevent motion. And the third one, usually due to apply loadings, reaction occurring at the supports or at points of contact with other body weight of the body. The third procedure for drawing a FBD is identify its loading and give dimensions. The first of all, indicates dimension for calculation of forces. Known forces and couple movement should be properly labeled with their magnitudes and direction. Letters used to represent the magnitudes and direction angles of unknown forces and couple moments. Establish X, Y, and Z coordinate system to identify unknown. Example 1. Identify the forces. A spool is having a weight of W, which is suspended from the crane bottoms. Consider FBD at A since these forces act on the ring. Cables AD exert a resultant force of W on the ring. Condition of equilibrium is used to obtain TB and TC. You can look at on the screen. Example 2. Identify the forces. Look at to the screen. The bucket is held in equilibrium by cable. Force in the cable equals to weight of the bucket. Isolate the bucket for FBD. Two forces acting on the bucket, weight W and force T of the cable. Resultant of forces equals to 0, W equals to T. The third example, the sphere has a mass of 6 kg and is supported. Draw a free body diagram of the sphere, the chord CE and the knot at C. You can look at on the first picture, second and third picture how we draw the free body diagram.